Okay, right. Let's kind of carry on with 231 to 235. So what we have here, exactly kind of similar to what we're doing, key factor analysis. We're trying to see who's giving us the greatest contribution based on the scarce resource. The scarce resource this time is labor. The scarce resource this time is labor. So our task is to find what the contribution is. First of all, let's just take your time and you'll get there. Cups, plates. So in terms of contribution, I need to say £2.50 less all of these variable overheads, or variable costs, sorry, forgive me. So £2.50 minus all of this thing here gives me 40p, 0.4. And £3.50 minus all of this gives me 55p. The question here now I have to ask myself, I'll just change my pen color, is how long does it take to make a cup? I spent £1.10 and it's £11 an hour, so that's really 0.1 of an hour. I spend £1.60 in terms of labor making a plate. It was £11 an hour, so £1.60 divided by 11 gives me 0.145 of an hour. That's how we look at this. So now I can find out what the contribution per hour is, right? By dividing 0.4 times divided by 0.1, which gives me 4. So technically I can make 4 cups in an hour. And here 55p divided by 0.1 gives me 3.7 something along those lines. The key point here is that I'm going to make cups first because it's giving me the higher contribution. So, well, let's just simply look at it. How many hours do we have? We have 10 operatives who work 140 productive hours a month. So that's 140 hours each. So that's 140 times 10. So that's 1,400 hours in total for all the operatives. I have demand for 10,000 cups, and each of those cups takes 0.1 of an hour, which means that's 1,000 hours in total. And therefore, if we have 1,000 hours for cups, then we have a total of 1,400. It means we have 400 hours left for our plates. And I'm told that we've done this already, that it takes 0.145 hours to make a plate. So therefore, 400 hours divided by 0.145 will take us to 2758 or something along those lines. And we round up, and that's 2750. So that's the process, right? It's the same as we did in earlier questions, I think 230, maybe 229. This idea of I need to make sure I can allocate best and whatever's left use for the other parties. 232. What are we doing over here? So again, they want to know what the contribution per limiting factor is. Pretty straight. Let's find the contribution first. Contributing income, contract income is 100. Materials are 5 times 5, which is 25. Skilled labor is 2 times 15, which is 30. Unskilled labor, 4 times 8, which is 32. And so what I now have, if you like, is contribution of 13. And it says this is the limiting factor here, the skilled labor. So we're basically using 2 hours of skilled labor to generate this contribution. So therefore the contribution per hour per skilled hour would be 13 over 2, giving us £6.50, and we have that there. This is an interesting one again, and what we have here is that currently your variable cost is 3. So let's say we have X and we have Y. Again, I'm jumping into it because you've read it. Yes, X and Y. So we have £3. Component X is 3. And component Y is in-house. Component X has a variable cost of £3, as does component Y has a variable cost of £3. Their direct divisible sort of fixed cost excuse me. The direct divisible cost of is 6,000 a year for 10,000 units or 10,000 components. So if I split that for X, that's 6,000 over 10,000. That's just on X, and then it's 7,500 over 10,000. That's just on Y. So you have 60p. In adding, you have to add on a 60p here, and you have to add on a 75p here. So these are direct divisible. Divisible, direct, fixed. This is almost trying to confuse us, but it is relatively variable because it's divisible. So we now have a total in-house cost of £3.60, total in-house cost of £3.75. What are our options? We can go out there and we can find this thing for £3.66. And we can go out there and we can find this thing for £3.60. So definitely make X in-house because it's cheaper to make in-house. Definitely outsource buying in Y because it's more expensive to make in-house. So buy in component Y and continue to manufacture X. Right, and then question 234. Again, it's very similar approach here. It says here that we're dealing with 500 units and someone's come and offered you 350. So let's look at what you're doing in-house. Currently you're spending 100, 75, and this directly attributable thing again of 82,500. Divide this by the 500 units. So 82,500 divided by 500 units takes you to 165. So all of this together gives you a cost of 340. So you're saving £10 on each unit. So the question says, if you go ahead, remember this is not, we're not interested in fixed costs and making these short-term decisions. So the question says, if you go ahead, how with buying this from outside? Well, you're going to be basically £10 worse off, if you like, and that's £10 on every unit, and you're going to buy 500 units. So that's you're worse off 5,000, if you like, on the 5. So that's the 10 times the 500 units, which is 5,000. So you're worse off. So the answer is A. And finally, in this group of sections and questions, let's look at the scenario here. Again, very similar. 2,000 windows a year, total cost of 100,000. Variable cost, direct labor 15, direct materials 20, and variable overheads 5. And then we have this direct attributable cost of 10,000 over 2,000 windows, right? And therefore that's sort of an additional overhead of 5. So currently in-house you're spending £45 on this thing. The options come along to buy it from outside for 44, saving you £1 on each window. So on 2,000 windows you have a saving of £2,000. And that's that. So yay, we should get the bottle out in a second. We're going to be completing the last questions in the next video.